It's good to see you back. So let's begin. By knowing how we've explored space, you can understand how events and people have shaped where we are today. Given our history in space, you may be able to imagine a future of space exploration and research. The rockets, satellites, and human space missions we're going to study today have helped us see space as never before. In this chapter, we'll discuss entering space, the act of placing spacecraft and people into orbit, and Space Comes of Age, where we describe recent events and trends. At the end of this chapter, we'll discuss the Air Force's role in space. But today, we'll begin with entering space. Here we have 5 areas of interest. Going into space describes how we started our journey into space. The Age of Rockets discusses how rockets were developed and used and why they were important to our exploration of space. Sputnik, the Russian moon, relates to how the space race began. Armstrong's small step tells the story of America's eventual triumph in the space race to the moon. And Satellites and Interplanetary Probes describes how we go well beyond our solar system to explore the universe. As far back as 300 BC, beginning with the Greeks, our ancestors explored space in their imaginations and from Earth's surface. People couldn't go into space and experience it until the early 1960s. Before that, they used their 5 senses and the instruments they created, like the telescope, to learn about the universe. You still do this today if you look through a telescope and imagine what it might be like to go to the moon. But early on, through myths and legends, and even before Leonardo da Vinci first thought about artificial flight, people wanted to fly. On December 17, 1903, the Wright brothers proved it could be done. But rockets made spaceflight possible. So let's begin with them. History tells us China first made rockets for military use against the Mongols in 1232. But let's bring military uses of rockets closer to our own century. William Congreve, a British Army colonel, developed incendiary rockets during the Napoleonic War. Later, the British used them to fire on Fort McHenry during the War of 1812. Our national anthem by Francis Scott Key refers to the rocket's red glare. After 1815, artillery improved, so rockets seemed less important. Still, people remained interested in and continued to think about rockets. In the 1880s, Konstantin Tsiolkovsky became the father of Russian cosmonautics by studying the use of rockets for spaceflight. A skillful theorist, he calculated the speed or velocity needed to go into space. He also suggested in 1903 that burning a mixture of hydrogen and oxygen could help rockets achieve a greater range. Today, the best performing rockets like the Space Shuttle use this mixture. The Russian government endorsed spaceflight and, in 1924, created the Bureau for the Study of the Problems of Rockets. Later, we'll see how much the Russians have contributed to rocket and space technology. What about the United States, you might ask? Well, the U.S. lagged behind Russia in studying rockets, except for one man. Dr. Robert H. Goddard believed that rockets, if powerful enough, could reach the moon or Mars. Dr. Goddard launched the first liquid-fueled rocket in 1926 and had lots of ideas for developing and using them. But our government didn't support his research. Here you can see Dr. Goddard standing next to his liquid-fueled rocket. Eventually, Goddard's great accomplishments were recognized, and NASA named one of its centers after him. Today, you can visit the Goddard Space Flight Center in Maryland. By contrast, the Germans were very interested in rocketry. The Treaty of Versailles after World War I limited Germany's production of heavy artillery, and rockets became the center of national attention. About 1923, rocket science took off when many scientific societies with student members like you formed to study rockets. When Adolf Hitler took power, this interest in rockets developed into the V-2 rocket, which was the world's first ballistic missile. Hitler saw the V-2 as a way to launch warheads over long distances without violating the Versailles Treaty. With this as background, Let's look at what happened after World War II. You know Germany lost World War II, but did you know Germany developed and launched more than 2,000 V-2 rockets during the war? When they lost the war, they also lost the German scientists who developed the V-2 rockets. Germany surrendered to the Americans. Dr. Wernher von Braun, his rocket team of over 500 scientists, and enough parts to make nearly 70 V-2 rockets. They became the basis of the U.S. rocket program. The V-2 rockets gave the Americans new information about magnetic fields, radiation, and cosmic rays, which we'll study more later. The Russians also hired German scientists who led the team that created Sputnik, which we'll learn about in a few minutes. V-2 rockets, like the one shown here, were used to learn more about rockets, the upper atmosphere, and the challenges of space. But when tensions between the U.S. and the Soviet Union began to escalate, our national security became much more important to the military. Rockets, later called intercontinental ballistic missiles, or ICBMs, were being developed that could deliver nuclear warheads. This activity helped spark the Cold War between the U.S. and the Soviet Union. During the Cold War, tensions were very high. When the Soviet Union launched the first orbiting satellite named Sputnik, or Fellow Traveler, in 1957, the space race began. At this time, the Soviet Premier Nikita Khrushchev tried to use the Russian success in space to prove that communism was better than democracy. Of course, the Americans believed they had to win the space race, so a rapid series of launches began the battle for national prestige. Things were really heating up. Fortunately for the U.S., by January 1958, the von Braun team launched into orbit America's first satellite, a modified Redstone rocket carrying the Explorer 1 payload shown here. However, the Russians had already pulled ahead of the U.S. by launching Sputnik 2 only 1 month after Sputnik 1, with the first living creature ever to orbit the Earth. The payload was a dog named Laika, which means little barker. But she died after her battery-powered life support system quit operating. Russia jumped farther ahead when they launched Sputnik 3, which carried a 2,970-pound geophysical laboratory into space, well beyond what the U.S. could do at the time. In the last chapter, we talked about the mission statement being an important first step in creating a space mission. The U.S. decided they needed to better define the mission, so they created the National Aeronautics and Space Administration, NASA, in October 1958. NASA's goal was to research spaceflight and aeronautics and to put the first person in space. From 1958, during President Eisenhower's term of office, until 1963, under President John F. Kennedy, NASA's budget increased from $90 million to $3.7 billion, more than 30 times larger. By 2006, NASA's budget was $17 billion. A year after NASA was formed, the Soviets reached another landmark in the space race by taking the first photographs of the moon's dark side with the Luna 3. At this point, the U.S. was losing the race for space. Unfortunately, NASA suffered several early failures in the space race. For example, the Mercury Atlas exploded 1 minute after liftoff, and the Mercury Redstone collapsed after the engines fired, but then cut out. Well, they were down, but not out. The U.S. came back to launch a chimpanzee named Ham in honor of Holloman Aerospace Medical Center. His flight was a short trip into space and back. Take a minute and think about the excitement of watching a really good competition, a boxing match, a car or horse race, or Olympians challenging one another. In the early 1960s, the whole world tuned into the successes and failures of these two competitors in space. The Russians' next success was a real blow to U.S. scientists. On April 12, 1961, Yuri Gagarin, shown here, completed 1 full orbit of the Earth. Only a few months later, in May and July 1961, the the Americans managed to send and return Mercury astronauts Alan Shepard and Gus Grissom without completing one orbit. But then, the Russians launched Herman Titov into space for an astounding 17 orbits of Earth. Finally, in February 1962, on the Mercury Atlas VI, John Glenn became the first American to orbit Earth. Glenn created another amazing precedent in 1998 when he became the oldest American in space on STS-95. Though behind, the U.S. had lots of momentum that would eventually help us win the race for space. Now let's focus on some of the other American successes during the space race. Though behind the Russians in crewed spaceflight, the U.S. recorded some firsts in communications satellites. In August 1960, Echo 1, seen here, showed how a large orbiting sphere could reflect voice and picture signals. A ground station transmitted voice and pictures toward the Echo 1 sphere in space, where the signal bounced off the aluminum sphere and returned to another ground station on Earth. Then, in July 1962, Telstar 1 relayed communications signals between remote locations on Earth. These two successes were the basis for today's communications spacecraft, which dominate worldwide communications, TV, radio, and other forms of electronic communications. Most people and nations want to be winners, so the U.S. eventually used nearly 2/3 of its entire space budget to send Neil Armstrong, Buzz Aldrin, and Ed White to the moon using the Saturn V rocket. Armstrong was the first man to set foot on the moon with the memorable words, "One small step for man, one giant leap for mankind," which thrilled the world on July 20th, 1969. At this point, many people believed the U.S. had won the space race. The U.S. eventually landed 12 men on the moon between 1969 and 1972. But successes after Apollo were just as important, even if they weren't as glamorous as the moon landings. In 1973, the U.S. launched America's first space station, an orbiting laboratory called Skylab. Then Apollo 18 docked with the Soviet Soyuz spacecraft in 1975 and marked the beginning of future cooperative space missions. In the next section, we'll talk about international space cooperation in the 21st century. NASA focused on the Space Shuttle program with Columbia's maiden voyage in 1981, while the Russians concentrated on keeping people in space by launching 7 space stations between 1971 and 1982. Their Mir space station marked a new generation of space habitat by making possible stays of longer than 1 year at a time. Today, many nations are involved in crewed spaceflight, including the Russians, Europeans, Japanese, and the Americans. In October 2003, the Chinese launched their first person into space. We'll talk more about these accomplishments near the end of our series of lessons. Human space voyages got a lot of media attention, but our satellites and interplanetary probes quietly revolutionized our lives. Although you could count on one hand the number of spacecraft flying today with people on board, robotic spacecraft and interplanetary probes number in the hundreds. Robotic satellites are navigation beacons and relay stations for radio and TV signals. They also watch our weather, track pollutants, and help our military defend our country and verify international treaties. Interplanetary probes, such as the Mariner, Viking, and Voyager probes, have deepened our understanding of the solar system. We'll learn much more about these spacecraft in later chapters. Take a few minutes to answer the questions on this slide. You may want to share your answers to the last question with the class and start a debate. In this section, we talked about the recent history of people, dogs, and chimpanzees in space, and overviewed early rocket development in Britain, Russia, and Germany. We viewed how the U.S. and Soviet Union competed fiercely during the Cold War. We saw that our national will and perseverance served us well, And with Armstrong's small step, the U.S. overcame its early disappointments to win the space race. Next, we'll move on to an exciting part of our discussion as space comes of age. We'll describe the current trends in space exploration, international space activities, space, big and small, as well as the new high ground and the future of space.